Got a boomerang to work on this time. A boomerang, something that comes back. And in this case, it's a 45-year-old Pioneer cassette deck that has decided it no longer wants to play tapes. Let's see what's wrong. It's back. This is a Pioneer CT-F8080 that I worked on, I don't know, maybe 4 months ago. 3 or 4 months ago, I guess. At the time, it had no sound. And the guy that I fixed it for, he says it's been working fine, and then he went to use it, and he doesn't get any tape movement in play. So, fast forward works, rewind works. When you've got an audio signal passing into it, I think he said record worked. Oh. Okay, there's only one channel's working on record. But play doesn't do anything. It just releases the button. This could be an interesting one. Anyway, the guy that owns it, he fully understands that it's got nothing wrong with what was, or nothing to do with what was done before on it, so he's prepared to spend some more money on this machine. Not a lot, but I get a kick out of all the people that have got these old dinosaurs. And I understand the reason why people like these units. I mean, this unit actually is cool. The fact that you load the tape in directly like that, that is kind of cool. But this machine's got to be 44 or 45 years old. So you got a lot of old electronics in here. Things just waiting to rear their ugly heads. So let's take this one apart and see if we can spot where the problem is on this one. So if I remember correctly, the last time this one was in, I know what I did because I went and looked up the video to find out what it was in. It was a regulator that had popped on it. But that's obviously not going to be the issue this time. So we'll have to do some testing and see what the heck is wrong and why the play solenoid is not engaging. But I mean, it's not even trying to turn on the motor for the reel. I think it uses a separate motor on this. It has a separate motor. I'm just not sure whether it uses this one for play or whether it drives the play off of an idler off of the capstan. And the capstan is turning, by the way. The capstan shaft is turning. So the capstan motor is running, so it's not bad. Okay, this is a solenoid controlled unit. We've got some switches in here. This is the record switch over here. This one is the play switch. And if we get the meter in here, I don't know if you guys can see it or not, but I'll try and get the meter in where you guys can see what's going on. If we go to the play switch here, okay, I've got 11.9 volts here on the switch, and when I push the switch in, it goes to 0. Now this should be what engages the solenoid. This could actually be a simple repair. You see? So it's trying to turn the system on, and the auto stop is then, of course, activating. If I push the solenoid over here by hand, will it play? So I press the play button and move the plunger, will it play? So the plunger is not moving. Are we getting voltage on the plunger? Let's just take a look at that. So we definitely have an electrical problem on this unit. Is it going to be a simple fix? I hope so. On the plunger I've got 12 volts, right, 12.3 volts here, and that's on one side, and on the other side I've also got 12.3, so one of these should go to 0. I hope it goes. If it doesn't go to 0, we've got a problem. Okay, it's not going to 0. Well, at least we know the plunger's not open. One of these sides should go to ground when it starts up. So something back on the control board here, maybe a broken connection, or it could be an open trace or a broken connection on this board. This one is it going to be easy to see? I think it is, because this board should be able to lift out, and I can examine the bottom of the board and see if there's any fault with any of the connections on there. So the plungers connect all this board here, but the wires for the plunger, the red and the brown wires for the plunger, come up down to this connector down here. I wonder if the connector's bad. Always a possibility that one of the pins has gone bad on this connector. That could be a possibility what the problem is. Or something on the board. I'll pull the board out and just take a look at, I think I can get this board out of here without too much trouble. Should be just held in place by 4 screws, and I should be able to lift it, because the switches here are not physically, I don't think they're physically connected. No, they're not physically connected to these push rods, so this board should lift out, and I can inspect the bottom for any cracked solder. Let's do that. That should be lifting the board out now. I just have to pry it up here, pop it out of those little pins. There we go. Okay, if I can clear this, better undo this tie, or we'll have wires everywhere. I'm just going to unplug this plug, get that out of the way. Undo this tie. It could be this plug too, right? But let's inspect the board. Certainly looks like there's a pin over here that looks like it's cracked, one of these wire wrap pins. And this one down here. And this one over here. And even this one here. Okay, this one looks to be bad here. This solder down here looks to be cracked from my point of view. What's that go to? That's the second one, and okay, that's the brown one. So this one here is the pin that traces to the play solenoid, and that comes down from there down here. I'm going to resolder this plug, and some of these pins here that look like they're dry. When we do those, and see whether it changes anything on this unit. I don't think it's that serious, the problem. I think the problem is right in here on this board. And I say that just from my experience on working on these units over the years. That a lot of times where you have these big, we call them pogo pins that go through the board. They're wire wrap pins. And a lot of times they didn't get them hot enough at the time, and eventually they crack. And there's a few of them down here that look like they're cracking right now. And you would think that, you know, somebody who has something like this is an older guy, but the guy that actually owns this one here is younger than me by about 20 years. He's actually the son of a guy that I used to do a lot of work for. His dad was a long-time customer at the shop that I worked at. And he looked me up out of the blue because when stuff started breaking down, he asked his dad, he says, "Hey, who was your friend that fixed this stuff?" And I get this call out of the blue, and the name didn't ring a bell. And then he told me what his dad's name was. And I said, "Oh, yes. Okay, what do you got?" And he's got a bunch of old stuff that he wants me to maintain for him. Going to do this plug the pins here. Now it could be the connector itself that plugs into here. They have been known to go bad, the springs in them, but generally just reseating them will fix that. These ones along the edge here. Same with these wire wraps. I've never been a big fan of wire wrapping, although it is fairly reliable, but still I prefer if it's soldered down and the pin is soldered down too. See, some of these pins have got wires wrapped on the top side. There's a regulator on here. I'm going to take a look at the connection on it too. And then we'll put the board back in and see if it has made any difference. See whether the solenoid kicks in. It's just the solenoid that's not kicking in, and it's not the solenoid. Now here's another cracked connection. This one's a pretty obvious one, right, where is it on camera? Right here. Of course you guys can't see it because there's a wire in the way, but that one there is a pretty obvious break. Right there, you can see it. There's a big regulator transistor on here somewhere. There's a couple of them. So let's see if there's any cracked connections around them, because they tend to produce a bit of heat. So anything that gets hot, you get the thermal expansion and contraction, so it can cause connections to crack. So we'll just, they don't look bad though. But there certainly were a few on here, namely these ones with these pins that certainly did look bad. So, and you see on the top side, the ones that didn't have any wires or anything on them, well, on the top side they have wire wraps on the top here. Just try putting this thing back together now and see whether I've made any progress. This white plastic gets really, really brittle. There we go. When it gets old, so we got to really kind of work very gently when you're dealing with this old gear. Okay, that's got the board back in. Is it lined up? Put the screws back in, and we'll plug in this connector and cross our fingers that the solenoid is going to kick in, and I'll be able to call them up and tell them that I got good news for them. But I can't get over how many people are still fiddling around with cassette tapes. I mean, it really amazes me that people are still, especially using old stuff like this. It might have been okay in the 1970s when it was new, but it certainly, won't hold a match, never mind a candle, to any of the more modern stuff. But people still like to play around with this old gear. I think a lot of it's just the look, right? They like the aesthetics of the brushed aluminum look as opposed to the more modern ones, which were all black and so forth. Okay, power is on. Is this thing going to work, or is it not? Fingers crossed. We'll go into record. Still only got one channel. So we have a second problem here. Either that or my plug on the back's not plugged in properly. That's always a possibility. Let's just make sure. Let's try the record side. Okay. Yeah, it's still dead. You see, no. This side it works. This side it doesn't. Oh, now it came on. Wonder if the... Must be right back here. It's got to be another broken connection on this board. So let's take a close look. So this is the input board, and when I was moving the connections when it cut in, this one be the outputs, and these two are the inputs, and this is the one here that wasn't working. I don't see any connection here, but some of these wire wrap pins, again, the pogo pins on the board here, some of these don't look very good. They look pretty flaky. There's also a switch back here, the switch between the DIN input and the line input, so I wonder if that switch is flaky. It certainly wasn't working, and now it is. And all I did was basically unplug and replug the input plug a couple times. Of course, it was the left channel. Now it won't cut out. So I don't know if there's just some oxidation on the inside of the plug, and it broke free. I don't know that it even records on this deck. You know, that's something I should find out, whether he actually makes recordings. I kind of get the feeling that he probably has a lot of tapes that were recorded like way back that his dad recorded, and his dad was a professional DJ. Worked in a radio station, and he's got some pretty awesome mixes. Plus, he's got a lot of tapes of his dad's program. Like he used to record his show, so he's got a lot of cassette tapes of his dad on the radio when he was in broadcasting. Throughout the years, he wasn't just in this market; he was in many other markets across the country. So he's got a lot of tapes, like a lot of air check tapes that were recorded when his dad was on the air. And I don't know that he's transferred everything over to digital yet, but I think probably this machine gets used a lot for playback and not really for record. Although this isn't the only tape deck he's got. I'm sure he's got other cassette decks, but he likes this one because of how it looks, the aesthetics of it. I think I will go over these connections here on the pins, just to be sure that they're not going to be a problem. So we just unplug it, and we'll just resolder these pins, and maybe I'll give that switch a shot of cleaner, because it could be that switch at the back too that is causing the problem. And then we'll give this unit a test recording and playback and see how it sounds. So back to that control board, it had to be one of those, probably one of the pogo pins, as I call them, that connect the wire wrap. Either that, or it was either the pogo pins or the this connector here. It was either one of these pins or this actual connector was bad. One of the two. These ones are just on the DIN plug, I believe. Yeah, these ones are on the DIN, so I won't bother with them. We'll give that switch a shot of cleaner, just to make sure that that wasn't why I was losing one channel. Okay, I got sound on both channels now. So just to give you an idea where the fault was, when we were testing this before, remember when I tested the solenoid? We have 12 volts on it, but when I go into play, it should drop to 5 volts. And it wasn't. So that was the giveaway that the solenoid wasn't engaging, that it wasn't dropping down to the proper voltage. There wasn't enough of a voltage drop across there to pull the plunger in. And typically how it works is that it's grounded momentarily to pull the plunger in, and then voltage, or the voltage was allowed to rise. Right, he's loading resistors. One's probably for the record solenoid, and the other one for the play, I would think. Let's see if my theory is right, because I don't have a schematic for this thing. I guess I could print one up, but let's just see if my theory is correct. What do we got on here? We've got 12 volts. I go to play. It goes to 5 volts, but on this side it's got down to 0, like to 1. So what it does is it grounds out, and then it grounds to pull the solenoid in, and one side is grounded and the other side is going to the solenoid. And this one here, I'm sure, is for the record. Is it? Yeah, okay, that's the record one, you see? So that's the limiting resistor for record, and that's the limiting resistor for the play solenoid. And they have to go to a dual voltage because the reason they do that, well, sometimes they'll use a switch too. This one might use a switch instead of a transistor. I bet you it does. Is there a switch? Yeah, there's a switch on here. So it's using a switch. And does this one have a switch as well? I bet it does. Is there a switch in here that gets activated? I'm sure there's a switch in here. Yeah, there's a switch. Can't see it, but there I can hear it clicking. So what happens is there's a switch that's normally when the plunger is open, the switch is closed, which shorts out the resistor. And then once the plunger activates and closes, the switch goes open. So it's actually not using transistors or capacitors. I was thinking perhaps I'm thinking ahead of the game. They weren't that smart back then. They didn't use electronic controls. These are just like the old Akais. They're fully mechanical, and they actually use a switch that activates, a mechanical switch that activates when the plunger is in, so that it gives it full power, and then once the plunger is pulled in, it doesn't need full power. The reason they drop it down is because you would burn up the plunger. You would burn up the coil on the solenoid. The schematic is kind of like this. I'll kind of draw it out for you guys so you understand what I'm getting at. Okay, here's my crude drawing on the back side of some UPS documents for that power station that was shipped in for me to do the evaluation on. And man, the paperwork they had to fill out for that thing because of the lithium-ion batteries that it contained. And the like cargo aircraft only from Hong Kong. Yeah, the paperwork that they had to put in to send that thing was ridiculous. Okay, so this is basically how this solenoid works for the play solenoid. The record solenoid is exactly the same. So you got a 12-volt source, and it goes through when the plunger is open. I'm kind of drawing this backwards as I went. When the plunger is open, you're on the normally closed contact. So your completion goes like this over towards the play switch, which is not pressed. When you press the play switch and close the circuit, your current flows through here, goes up through here, and back. You've completed the circuit, and you've got your full 12 volts being pulled across the coil. That creates a strong magnetic field. The plunger pulls in, which now switches the contact. So this breaks, and now it's completely open. So the current can no longer flow through the switch. The current now has to go through the resistor, and it continues on its way to ground. So now we've got about 5 volts here on this side of the coil for the solenoid. That's to limit the amount of current that can go through the solenoid. The diode is here. That's to provide kickback, because of course when you remove the voltage, remove the current flow, current is going to stop when the stop button's pressed and the switch goes back open. Now you don't have a completed circuit. You're going to have a high voltage equal to at least what went into it or more, because the magnetic field is going to collapse. It's going to collapse very quickly, and you're going to have a back EMF, which is what we call flyback. And that would create an opposite pulse. So you'd have a negative voltage kicking out this side, which would be, or pardon, you'd have a negative voltage on this side, positive voltage on this side, which would add to the existing voltage. So if your collapsing magnetic field produced 12 volts, you would have 12 volts added to the 12 volts, and you'd have 24 volts kicking out on this line here, which would then could cause a spark and burn the contacts in the switch. So the diode is there so that when the magnetic field collapses and you get a voltage spike across the coil, it will now short it out, cancel that out, so that there's no high voltage kick that's going to travel down and burn up the contacts in your switch. So if the diode goes open, the switch itself is also going to fail very quickly. And that's why you always see a diode on the backside strapping these solenoids that operate on DC. If it was an AC type of solenoid, then you would see a snubber array. And how what a snubber array is typically a resistor and a capacitor. So you have a resistor and a capacitor like that placed across the coil, across the solenoid coil. So that would cancel out the kickback when the magnetic field collapses on an AC type. And you'll find all those old Akai reel-to-reel machines, they'll have these little parts. Usually they're little orange parts, and people think they're capacitors, but they're actually not. If you look on the side of them, they'll typically have the schematic. It'll show a resistor, and a capacitor across it. And that's what it'll show on the thing, and it'll have the two pins on it. It looks like a capacitor. Most of them are orange in color, at least the ones I've seen are orange. Sometimes they're green, but that's a snubber. Does exactly the same thing, because the big old reel-to-reels, they use AC. The switches are actually switching line voltage AC to the solenoids on those big old Akai reel-to-reel, and I'm sure some of the others, but the Akai ones are the ones that I'm familiar with. So let's take a look at the tape transport on this. You can go from one mode to the other. That'd be good for the tape. Yeah, you can go right to fast forward, right to rewind. Don't have to go to stop on this. So let's do a recording on here. I'll set my recording bias up. It's got a peak indicator too, eh? Okay, that should be enough. Let's just rewind this back. Memory stop is on, good. And it should start playing right about now. It's got playback controls too, which actually control the meters. That's not bad sounding, to tell you the truth. Holy smoke! Well, I can't complain about the sound on this one. That is fantastic. You don't even have to clean the head because the guy that owns it is pretty particular about keeping his machine clean. You know, he's I wouldn't call him an audiophile, but I'd call him getting close to being an audiophile, because I've seen some of the stuff that he's got in his house, and he does have modern stuff as well, but he loves his vintage stuff. And I say this piece is in actually pretty good condition, cosmetically wise. It looks pretty good. Anyway, another one saved from the scrap heap, so we can claim victory. Look at the motor on this thing. Like, this has got a really beefy motor. You know, you see a lot of tape decks, even some of the real fancy high-end ones that start with Knack and end with Michi, have really low-end motors. Yeah, this thing. I don't even know if this one's adjustable speed. This might be mechanically. I guess that's a speed adjustment on the back there. Anyway, but look at the size of that motor. It's huge. Like, it's a solid motor. It's got a huge pulley on it. I don't know if you guys can see it or not, but see if I can lift this. This thing weighs a ton too. Can you see the pulley or not? Anyway, it's got a big flywheel. You can see the flywheel in here. It's got a fairly wide belt. There's nothing wrong with that belt too. I can slow it down, and it actually slows the motor down, so the belt is in good shape. It's got this big flywheel for low wow and flutter, and just a neat old tape deck. Anyway, that's it for this one. Maybe I'll see this one again when it breaks again. Who knows? Thanks for watching. We'll catch you in the next one. Bye for now.